Hi everyone and welcome back. Now today's video is going to be quite exciting because we are going to launch our first virtual machine in AWS through Terraform. Now, one important part that we need to note is that depending upon the provider that you work with, the name that you associate with virtual machine also differs. For example, if you're working with DigitalOcean, they do not call it as virtual machine, they call it as droplet. And same with lot of other providers as well. So when we discuss about virtual machine from AWS point of view, it refers to EC2. What is EC2? It is Elastic Compute Cloud, and in short it is generally referred to as a virtual server or virtual machine that you launch in AWS. So this is one important part to know. Now, whenever you are creating a new virtual machine or a new EC2 instance in AWS, there are certain considerations that you have to keep in mind. The first primary consideration is related to region. Now most of the cloud providers, they support multiple set of regions. It can be in Asia, Europe, Africa, Australia, US, etc. So whenever you create a new resource like a virtual machine, you need to select in which region you want to create a resource into. For example, from AWS point of view, you see there are multiple set of regions that are available. You have the Mumbai region, you have the Australia region, multiple regions in US, multiple regions in Europe, a region in South America and so on. So in which region you want to create your server? This is an important consideration to keep in mind. Second important consideration is related to the virtual machine configuration. So a virtual machine can have its own set of CPU, memory, storage, operating system and so on. So while you are creating a virtual machine, you'll have to define the specifications related to all of this. Some user might want a operating system based on Windows. Some user might want Linux and so on. So whenever you are writing the Terraform code, you'll have to specify these set of aspects. Alright, so that's the high level overview, and with this, let's get started. Now, before we start writing the Terraform code, I also wanted to show you on how you can create a new virtual machine in AWS from a demo perspective, so that while we are writing the code, it becomes easier for us to understand on what exactly we are doing. Now, as we're discussing, EC2 instances are referred at an overview related to virtual machine. So when we search for EC2, it states virtual servers in the cloud. Now, currently there are multiple regions. If you see, there are multiple regions in AWS. In which region you want to create the resource into, you'll have to define it as part of the Terraform configuration, which we will be doing in just a moment. However, before that, let's go ahead and quickly try it out manually. Now again, you do not have to create a new virtual machine manually in AWS. I am doing it just so that we understand the workflow. Alright, so let's go ahead and quickly create a new EC2 instance. You can give it a name. Let's just call it as manual EC2. Then what you'll have to specify, you see you have a Amazon machine image. So this is nothing but the operating system associated with the server. So there are multiple operating systems that are supported. Amazon Linux, Mac OS, Ubuntu, Windows, etc. I'll use the Amazon Linux. The next important configuration is the instance type. Instance type is a combination of CPU and memory. If you'll see, there are multiple instance types that are available. The one associated with the free tier eligible, that means that if you create a virtual machine with this instance type, you will not be charged as long as you are part of the free tier program, which is the default for all the new AWS accounts. So this specific instance type has 1 vCPU and 1 GB of memory, which is free tier. However, if you go a bit down, you will have much larger instance types as well. For example, C3.8x large has 32 vCPUs and 60 GB of memory. So again, this is going to be quite expensive if you work with. However, we are going to work with the instance type which is associated with a free tier eligible. This is the second important configuration. The third is related to the key pair, which is related to authentication. How will you log in? I'll keep it simple. I'll just say proceed without the key pair. And that's about it. I'll go ahead and I'll launch the EC2 instance. Alright. So here you see it states successfully initiated the launch of instance, and our new instance creation is in process. So the aim of today's video is to go ahead and create a new instance in a very similar way, but through Terraform. Alright, that is the primary aim. If I refresh once more, you see the instance state is now running. Great. So one of the first things that we'll do in our desktop, we'll create a new folder. Let's just call it as KP Labs Terraform. All right, let's quickly open this. And what we'll do, we'll add this folder as part of our Visual Studio Code. Now again, there are multiple methods. You can open Visual Studio Code and add the folder manually, or you can also go inside the folder and you can just say open with code. Alright, so now we are inside this specific folder. So first, let's create a new file. I'll just call it as first_ec2.tf. So the Terraform code that you will write, make sure that whatever file name that you give, that is okay, but the extension should be .tf. Now, at this stage, we have decided that we are going to create a new virtual machine in AWS. So from the Terraform page, we are more interested in the AWS provider. So this is the AWS provider. If we go to the documentation, it will take us to the relevant page. Now, I'll also be adding this specific link after this video also in our GitHub page so that you can reference to it. Now, the first important part for any provider is to configure the authentication related areas. So for AWS provider here, let's go a bit down. I'll go a bit down into the authentication here. And here they have provided a basic usage on how you can define the authentication credentials in Terraform. So I'll copy this, and within the Terraform code, I'll go ahead and I'll paste it here. Now, if you'll see, we have defined a provider of AWS. This is simple to understand. Now, depending upon the provider that you use, this specific name would change. It can be provider of GitHub, provider of Azure, etc. The next important part is the region. AWS has multiple regions, in which region you want to create the resource. Now, if you see the available regions, each region has a specific code. So Singapore region has a code of AP Southeast 1. If we go to the North Virginia region, it has a code of US East 1. So we will be creating virtual machine in the US East 1 region. So let's go ahead and change it to US East 1. The next important area is the access and secret keys. This is something that we had generated in the earlier set of videos. So let's go ahead and replace these. So I have the access and secret key that I've added to my notepad. Let's copy the access key. I'll just add it here. Let's copy the secret key and I'll add it here. Alright, so our main configuration related to the credentials have been set. Now we need to define in Terraform what are the resources that we want to create. Now if we look into AWS, virtual machine is one of the resources that you can create. If we look into the available services that AWS provides, let me show you. So you see, they provide services related to wide variety of use cases. So you have database services, compute services where you can launch virtual servers, the containers related to Kubernetes, the blockchain services, and so many others. So which service you want to create is something that you'll have to decide. Now we have already decided that we will be working with the EC2 instances. So from the Terraform documentation also, if you look into the AWS provider, there are so many services that are available on the left hand side. So what we are interested in is the EC2. So let's go a bit down. So you have the EC2 as you see. Let's open this up, and under EC2, the one that we are interested in is AWS_instance. Now question comes is why there are so many options that are available here. So we can also find it out. So generally in the EC2 console, you see on the left hand side, there are so many options. One of the options is key pair. So in EC2, if you want to create a key pair, then you can click on this AWS key pair option. However, we are planning to create a new instance. So we'll click on AWS_instance here. Now, as soon as we open this, it basically is showing us the reference code to create a new EC2 instance. Along with that, it is also showing you all of the options that you can use while creating the instance. For example, whenever you create a new instance, there are so many options that you see related to the networking, the IP address, the firewall. If we go into advanced details, you see there are so many options that are available. So all of these are also directly referenced here in the argument references section. However, our main aim is to create a simple EC2 instance and we'll keep it simple for today's video. So in the example usage, this is a great thing. In documentation, they have given example usage for wide variety of resources. For example, if you want to create a key pair, again here they have an example usage. You can directly copy it from here and add it as part of the code. And this is the reason why things becomes much more simpler. So let's do one thing. Let's go ahead and define this. So within our TF file, I'll say resource of AWS underscore instance, and you can just give a name. I'll just call it as my EC2. You can give any name that you want, but make sure that this AWS instance remains to be the same. All right. And now you can specify the configuration of your EC2 instance. If you remember, whenever you create a new EC2 instance, one of the primary and the important part is the operating system image. So this is where you'll have to specify it. So if you look into the code, the first line is associated with the AMI. So let's specify AMI, and then you'll have to specify the AMI ID. Now in AWS, for each region, they have a separate AMI ID. For example, here you see there is an ID ending with 9F57. This is for Singapore. Now, if you go to the North Virginia region, this specific AMI ID will change for the same set of operating system. So here you see for North Virginia region, the AMI ID is ending with 8778. So although it refers to the same OS, but the AMI ID changes for the region. So I'll copy the AMI ID here and I'll add it over here. Now make sure that in case if you are not using the US East 1 region, make sure to replace the appropriate AMI ID. The next important part is the CPU and memory configuration. And where do we find that? It is part of the instance type section. So in the documentation here you see you have instance underscore type. So let's say instance underscore type, and within here I'll say t2.micro. All right. And that's about it. This is the only primary thing required, and our EC2 instance should be created. Let's go ahead and try it out. Now from the terminal, you have to ensure that you are currently in the same folder as kplabs-terraform. All right. So for example, if you open up the terminal directly from desktop, currently I am not in the folder of kplabs-terraform. So I might have to go to desktop. I might have to go to the folder of kplabs-terraform. Alright, this is something that you need to keep in mind of. Also for the newer set of operating system like Windows 11, you can directly open the terminal from here. Now, whenever you write your first Terraform code and you add a new provider configuration, the first command that you need to run is Terraform init. Now note that we will be discussing about this in great detail at a later stage. However, at this stage, let's go ahead and run the command directly so that we understand the high level workflow. So once you run the Terraform init, Terraform will go ahead and download the appropriate plugins associated with the provider that you have defined. So we have defined a provider of AWS in our code. So Terraform is downloading the appropriate plugins associated with that provider so that Terraform can integrate and connect with AWS to deploy the resources that you have defined. So this stage can take a little amount of time, maybe a minute or two, depending upon the overall size associated with the provider plugins. Once you have initialized, the next important step is the Terraform plan. So when you run the Terraform plan, it will show you what it will create or destroy in the environment based on the code that you have specified in the Terraform file. For example, here it is showing that Terraform will be creating a new AWS instance based on this specific AMI and based on this specific instance type. All right. So you can go ahead and verify if everything is correct here. Now, once you have verified that, all right, all the configurations that you see are correct, now you want to go ahead and create the resource in AWS. So now what you can do, you can run the Terraform apply command. Now note that when you run the Terraform plan, it will not create the resource, but it will show you what it is intending to create. If you want to create the resource, you run the Terraform apply command. So now at this stage, again, it will show you what it is planning to create and whether you want to create it or not. So here I'll specify yes. So at this stage, the creation of our first EC2 instance has started in the North Virginia region. So let's quickly wait for a moment here. Alright, so it took around 37 seconds and our EC2 instance is created. So now if we want to verify in the North Virginia region, let's go back to the EC2 service. You see there is one instance that is running based on t2.micro here. Alright, so I hope with this you understood how simple it is to create a new resource in Terraform. So let's do more interesting thing. Let's say you want to modify the instance configurations. For example, here you see that this instance that is created, it does not have a name. However, you want to add a name. Now generally in AWS, if you want to add a name to the EC2 instance, you can go to tags and you can create a new tag with the key of name. So what we'll do, from the documentation, here you see that there is a tags that they have added. The key here is name. So let's modify our code. This time we'll add tags. And within here, I'll say name. And in the value, I'll say my first EC2. Alright, I'll go ahead and I'll save this. Now back to the CLI. Let's run the Terraform plan once more. This time you see it is showing that 1-2 change. So there will be one change that Terraform will be adding and the change is related to tags. So once you have reviewed this, you can go ahead and do the Terraform apply. Let's do it once more. I'll type yes. Great. So the apply is completed. Now if you go back, let's refresh. This time you see a new name has been added to our EC2 instance. Alright, now at a later stage, if you no longer need the name, let's revert to our base code. We'll keep it simple. This time you can directly run the Terraform apply. I'm just showing you different methods. Note that Terraform plan is an important command to run in production environments to see what are the changes. And this is the reason why in Terraform apply also the overall plan will run and it will show you what exactly it is intending to change and it waits for the input. So here I can say yes and it will go ahead and it will remove these tags. Alright, apply is completed. If we refresh, the name again went away for our EC2 instance. Great. So I hope with this you understood the base workflow on how resources can be created. Now one thing to note here is that this provider configuration would remain to be the same. Today you are creating a virtual machine. Tomorrow you might be creating a different resource in AWS. So this resource part can change, but the provider part will always remain to be the same, primarily because you are working with AWS and the authentication is an important area that Terraform needs to perform the operations. So that's about it. Again, I'll be adding all of the codes that we have used in today's video as part of our GitHub page, also as part of the next document lecture for easy reference. So with this, we'll conclude today's video. Hi everyone and welcome back. Now in today's video, we are going to discuss about the resources and providers in Terraform in more detail. Now one of the main benefits of Terraform on why so many organizations have started to use it extensively is its support of multiple providers. So depending upon the type of infrastructure and resources you want to create, you can use the appropriate Terraform providers accordingly. For example, Terraform has wide range of providers from AWS, Azure, GCP, Alibaba, Kubernetes, etc. So let's go ahead and also quickly look into it. Now, when you explore the Terraform registry website, which is registry.terraform.io, here you see that there are more than 3000 providers that are available. Now I remember around 1 year back, this was somewhere around 700, but now this is 3000. So you can understand the great benefits and adoption that Terraform is gaining across the world. Now, if you look into the providers, you will get the entire list of providers that are available. You see the pages are quite huge. So depending upon what exactly you want to create, you can use the appropriate providers accordingly. Now, one of the important learnings for today's video is associated with the provider plugins. Behind the scenes, a provider is a plugin that lets Terraform manage an external API. So whenever you add the provider configuration block in your TF file, one of the first commands that you'll have to run is Terraform init. If you remember in our practical video, we had run Terraform init. So what does the Terraform init do? It downloads the appropriate plugins associated with the provider that you have defined in the TF file, and where these plugins are downloaded to, they are downloaded to a .terraform directory. So if you remember, we had run the Terraform init command, and here it is installing a specific provider plugins. In this case, it is associated with HashiCorp AWS, and these provider plugins are stored in the .terraform folder. So let's go ahead and look into it. Now in the KP Labs Terraform folder, you see that we had created first underscore ec2.tf. Rest all of these files were automatically created. One of the important folders here is .terraform. If we open this under providers, let's open this up. You have HashiCorp, you have AWS, the version, and this is the exact plugin that was downloaded. The size is around 300 MB. So the overall size of plugin is also quite big. However, this can manage the resources associated with AWS provider. Alright, so I hope with this you understood the important learning one. Now tomorrow, let's say that you want to work with Azure. So first thing that you'll have to do is you have to specify the provider of Azure within the TF file and run the Terraform init so that Terraform downloads the appropriate provider plugins associated with Azure. So in fact, let's go ahead and also try it out for better understanding. Now if we explore the Azure provider, in fact, let's jump to the documentation. You see it's provider of Azure RM. So let's go ahead and quickly define it. So within our first underscore ec2.tf, I'll just say provider of Azure RM, and that's about it. This is the only thing that you have to define to download the appropriate provider plugins. Now note that if you want to create resource in your Azure environment, you'll have to specify the credentials, but this specific line is enough for the Terraform to download the appropriate plugins. So from the CLI, you can run the Terraform init command once more. Now again note that whenever you define a new provider, you have to run the Terraform init, alright? Now this time it is installing the Azure provider, and we know where exactly it will install. Let's go ahead and find it out. So within our Terraform folder, you have this time Azure, and within here you see you have the appropriate plugins. This is of size 184 MB. Great. So I hope with this you understood the provider plugins in a better terms now. The second important learning for today's video is the resource block. So at a high level overview, resource block describes one or more infrastructure objects associated with a provider. For example, in this screenshot, you have specified resource of AWS underscore instance. So this describes that you want to create a new EC2 instance in AWS. If you want to create a new user in AWS or maybe a new database in AWS, then this resource block will change. For example, there can be multiple resource blocks. AWS instance is one, then AWS underscore ALB, which is for the load balancer, is second. Then you have IAM underscore user, which is used to create a new AWS user. Then you can have a different resource of DigitalOcean underscore droplet for DigitalOcean environments and so on. So whenever you want to create a new resource in any provider, you will have to specify this resource block, and this part AWS underscore instance or AWS underscore ALB, this is defined in the documentation, so you can directly use that. Now when we discuss about resource blocks in more detail, there are two important areas here. First one is that it declares a resource of given type. So your AWS underscore instance, you can call it as a type. So this is a resource type with a given local name of my EC2. Alright, so this resource type cannot be modified. If you want to use the EC2 instance related configuration, you have to use this specific resource type. The second part here, which is the local name, this is something that you can modify. So in this case, it is my EC2. You can give any other name as well. Now, let's say that you want to create two EC2 instances. So at an overview, the combination of resource type and the local name serves as an identifier for a given resource, and it must be unique. For example, you have one specific block here. You can also add one more block. So in the second block here, you see that the AMI associated with the server is different. Here you have a larger AMI ID, here you have a smaller AMI ID. This might be associated with a different operating system altogether. Again, this is just for an example. So when you have two separate instances of different configuration, then the resource type will remain to be the same. However, this local name, my EC2 and web, this must be different. So in fact, let's also explore this practically. Now, when you copy this specific resource block, in fact, let's try once more. All right. This time I'll just say t3.micro and AMI just 123. All right. So this is a different server and configuration accordingly, but the local name we have kept it same. So let's see whether Terraform works or it gives an error. So I'll clear the screen. Let's quickly do a Terraform plan. And immediately you see we got an error stating that the my EC2 was already declared and the resource name must be unique per type. If we make use of a different name here, let's say web, let's save this. And now if we run the Terraform plan, you see it is working well. It is trying to create one more EC2 instance based on a specific AMI ID and based on a specific instance type. So let's go ahead and remove this since we do not want to create an additional EC2 instance here. Now, here one important point that we need to keep a note of is that you can only use the resource that are supported by a specific provider. For example, in this screenshot, we see that you have a provider of Azure RM. However, we are declaring the resource associated with the AWS underscore instance. So this resource AWS underscore instance is associated with the AWS provider. So only the AWS provider plugins will be able to handle this block. However, if you have just declared provider of Azure RM and there are Azure RM plugins, those plugins will not be able to handle this block. Alright, so this is one important part that you also have to keep a note of. Now one thing, let's discuss Azure this time. So again, for Azure, there are multiple set of services that are available. So let's take an example of Azure Kubernetes Fleet Manager. So here you see that it is using the resource of type Azure RM Kubernetes Fleet Manager. So this specific resource can only be managed by the Azure provider plugin. If you use the AWS provider plugin, it will not work. However, a single instance of a folder can have multiple set of provider plugins. For example, I can use AWS provider plugin, the Azure provider plugin, etc. As we have seen in a .terraform folder, we have plugins related to both the AWS and Azure. Just to quickly show you, here you see we have plugins related to both AWS and Azure. So this means we'll be able to define both the AWS and Azure related resources. Now, one of the important questions that I have received from so many users is that Zeal, the Terraform looks good and easy to learn. However, do I have to learn Terraform for each provider? Because now we have seen that there are more than 3000 providers that are available in Terraform. Now, today you are working with AWS. Next year you are going to work with Azure in a different organization. So do you have to learn Terraform from scratch? And the answer is no. The core concepts, the standard syntax remains same across all of the providers. So this means that if you learn the core basics of Terraform, you should be able to work with any providers quite easily. Alright, and in this course we are going to focus on the Terraform core. So although we use AWS as our base for demo, the aim is always to understand the core features of Terraform, which will allow you to work with all of the providers quite easily. Now, one more important thing that I wanted to share before we conclude this video, because once you start working with Terraform in a real world environment, you might come across some issues, you might come across some bugs with the providers, etc. So here it is important to note that if you're making use of a provider that is officially maintained by HashiCorp, it does not mean it has no bugs. It can happen that there are certain inconsistencies when you run Terraform versus the expected output. So in such case, you can always raise the issue at the provider page. For example, Terraform has multiple GitHub pages associated with a different set of providers. In case if you come across issues, you can always raise it. Many a times it happens, although this is not very often because there are millions of people who uses the provider. So you will not come across bugs that often, but sometimes it can happen and you can raise the issue, or if an issue is already raised, then you can wait for the new update. In fact, let me also quickly show you this. Let's go back to the Terraform registry. Let's explore the AWS provider. Now this AWS provider, if you see, downloads this week 18 million, download this month 64 million. So chances of you encountering a bug or a issue are quite less. However, it can happen that you come across them. In such cases, what you can do, you can go through the GitHub page associated with the provider. For example, this is the GitHub page associated with the AWS provider. And within here, you will generally see there are multiple set of pull requests, so new updates that are coming. You also have the issues here, some of the issues related to bug documentation and so on. So this is also a place where you can find the issues, or you can also raise a issue over here in case if you come across any. Alright, so these are the high level pointers related to the providers and resources in Terraform, and with this we'll conclude today's video. Owned and maintained officially by the HashiCorp. Second, providers are related to the partners. So these providers are owned and maintained by the technology company that maintains a direct partnership with HashiCorp. And third type of providers are associated with the community tier, which are owned and maintained by individual contributors. So let's go ahead and quickly look into it from a practical point of view. Now in the Terraform registry page, if you look into the providers that are available, you see that there are three different tiers: official, partner, and community. So you can go ahead and quickly search for the official providers. So all of these providers that you see, they are officially maintained by HashiCorp. You also have the providers that are maintained by the partners. So you see there are multiple providers at this stage, like Alibaba Cloud, Oracle Cloud Infrastructure. They are maintained by the partner. As we were discussing, partners are nothing but the technology company that maintains a direct partnership with HashiCorp. And the third one are the community tier providers. So these are written and maintained by the individual contributors. Now note that when you start to work with Terraform in a production point of view, you should always try and use the official providers. Now Terraform has official providers for most of the popular technologies related to cloud, related to Kubernetes, Active Directory, various other HashiCorp products, and so on. Apart from that, you can also use the partner ones. These are also quite stable. However, you should avoid, if possible, using the community providers. It can happen that the community provider plugins has bug, and since these are maintained by the individual contributors, they might not get time to fix it. So this is something that you have to keep in mind. The next area to note is the provider namespaces. At an overview, namespaces are used for the overall organization of providers. So when you discuss about the official providers, they have a namespace of HashiCorp. Partner provider have the namespace name associated with maybe third-party organization like MongoDB, MongoDB Atlas. And community provider, they might have a different set of namespace name. So let's go ahead and quickly also look into this. Now, let's open up one of the provider. In fact, let's open up two official providers, which is AWS and Azure. Now this AWS provider, if you look into the URL, it is in HashiCorp. So you have registry terraform.io providers HashiCorp, then AWS. Similarly for Azure, you have providers HashiCorp Azure RM. So this HashiCorp that we see over here, this is the namespace that we are discussing associated with official provider. So any official provider that is being released by the Terraform will have the namespace of HashiCorp. So again, you see you have a namespace of HashiCorp here, and even for Active Directory, you have a namespace of HashiCorp. This is first part. Now, when we discuss about the providers that are maintained by the partner, they might have a different name. So let's take an example. Let's open a partner here. You have Alibaba and Oracle Cloud Infrastructure. Now, if you look into the namespace here, it is different. It is not HashiCorp. Similarly, for Oracle, you see it is Oracle, OCI, etc. So this name would change from partner to partner. All right. And same goes with the community. Let's also explore the community provider. Now, if you look into the community provider, let's open up 3 of them. Now, this has a different name. So, one password has a different name altogether. Then this one has a different name. Then this one has a different name and so on. All right. So, this is what the namespace are, and it allows the better organization. Now, one of the important parts to learn here is that Terraform requires explicit source information for any providers that are not HashiCorp maintained using a new syntax in the required underscore provider nested block. So let's understand this. So at this stage, we have been using the provider of AWS and we used to specify region, access key, secret key, etc. Now this block works perfectly well primarily because this is a HashiCorp maintained provider. However, the provider that are not maintained by HashiCorp, here you have to make use of required underscore provider nested block, which looks something similar to this. So here you see you have a required underscore provider nested block, and then you have to specify the exact source, which is DigitalOcean/DigitalOcean. So again, the namespaces might be different. So you'll have to specify this entire part. And this specifically also applies to the community set of providers. Let's quickly look into it. So from the Terraform registry, let me give you one example. Let's open up the DigitalOcean provider here. So this DigitalOcean provider, you see, it is of type partner. So again, the downloads are quite extensive, 25,000 this week. So let's go ahead and try it out. Now within our Terraform code, I'll say provider of DigitalOcean. All right. And let me save this. Let's run the Terraform init once more. And immediately here you see it states failed to query the available providers. And where is it trying to find a DigitalOcean provider? It is trying to find in this namespace, which is HashiCorp/DigitalOcean. And the exact URL is registry-terraform.io/HashiCorp/DigitalOcean. Now we know that DigitalOcean provider is not part of this HashiCorp namespace. So what you'll have to do, you'll have to specify the exact namespace, which is DigitalOcean/DigitalOcean. So I say DigitalOcean/DigitalOcean. Let me save this. We'll clear the screen. Let's do a Terraform init. Again, here you see you got an error. So in such cases, what you'll need to do, you can use the Terraform required providers. For example, if you look into the documentation, you'll already see a block associated with this, so it becomes simple. So I'll copy this. I can use this. I'll save the change. Let's clear the screen. I'll do a Terraform init. And you see this time it is able to successfully install the appropriate provider plugins. All right. Now, one more thing that I wanted to show you to avoid any confusion is that this required underscore provider block can also be used along with the HashiCorp maintained providers. For example, let's use the AWS provider. And if you look into the example usage again here, they have made use of the required providers block. Now there are a lot of configuration and settings that you can add as part of this Terraform block. We will be discussing about this in great detail in the upcoming set of videos. However, the aim was to understand at an overview that with the HashiCorp maintained providers, you can just use the basic provider block as well. And it is not mandatory to use required providers unless and until you want to customize things based on a specific use case. However, for various community providers or various platform specific providers, using the required underscore provider block is essential. So with this learning, we'll conclude today's video. Hi everyone and welcome back. Now in the video associated with the resource and providers, we were discussing that even though you are comfortable with Terraform from the perspective of one specific provider, you will be able to comfortably write the overall code for different providers as well. So in today's video, in order to demonstrate this practically, we are going to take an example of one more provider and we'll look into how we can configure the resource associated with that. And the provider that we will be working with for today's video is going to be GitHub. GitHub, as you know, is one of the most popular hosting service for Git repository in the world, and this is the reason why we are going to make use of a GitHub provider. So what is the aim of today's video is to create a new GitHub repository using Terraform. Now, in our initial learning, we know that the authentication and the authorization stages are one of the most important ones. So when you start to write Terraform code for GitHub, Terraform will need the GitHub credentials in order to connect and create the resource. So let's do one thing. First, let's explore the GitHub provider in Terraform. Now from the Terraform registry, I'll quickly search for the GitHub provider. So let's open this. So again, you see this is as part of the partner tier. So let's quickly jump to the documentation. Again, here you see downloads this week is 500,000. So a lot of users are using it from Terraform point of view is concerned. Again, I'll be adding the link to the documentation along with the code that we use for today's video in our GitHub page so that you can easily reference it. Now in the GitHub provider, here you see that a required providers is mentioned and the source is integrations/GitHub, which is this specific part. And then you have the provider of GitHub. So this is one important part. Apart from that, as we know, authentication is an important area. So we'll have to quickly look into the authentication part here. And what is the authentication approach that it needs is the token. So let's do one thing. First, let's go ahead and copy this code. And within our Visual Studio, we'll create one more file called as github.tf. All right. So at this stage, we have one file of first_ec2.tf, which has the basic ec2 instance resource. And in the new file of github.tf, we'll add this specific code. So our GitHub provider is added here. The next important part is the token. So let's go a little down. The token can be specified in the provider of GitHub. So let's add it here. So I'll say token is equal to, and we have to fetch the token. So what we'll do now, we'll go ahead and generate the token from GitHub page. So in GitHub now, again, here one of the prerequisite here is that you need to have a GitHub account. If you do not have it, you can just quickly sign up for GitHub. It's a very simple process. Anyways, so let's go to the settings. And within here, we'll go to the developer settings. Within here, we are interested in the personal access tokens. Let's use the fine-grained tokens here and we'll generate the token. So token name, let's just call it as Terraform. We'll leave everything as default. And the repository access, let's just use all repository just for simplicity. And then the repository permissions. Within here, you have the administration, which is repository creation, deletion, setting, teams and collaborators. So here I'll say read and write access. Let's go a bit down. We'll leave everything as default. We'll generate the token. All right. So this token is generated. Let's copy this. And within here, let me just supply the token. Again, this is a big token. Once done, just save this. Now that we have added a GitHub provider, the first thing that we'll have to do is Terraform init. So this will go ahead and download the appropriate provider plugins. All right. Now at this stage, we have not really specified what we want to do in GitHub. We have just specified the provider configuration. So what we want is we want to create a new repository. So creating a repository is very simple. So you specify the repository name. In fact, let me quickly show you. I'll just say test01. You can make it public or private and you can just create a repository. So this is what we want to create through Terraform. So let's go ahead and try it out. So as part of the GitHub provider under the resources, there are multiple resources that are available. We are more interested in the GitHub repository. So creating a GitHub repository overall is very simple. If you'll see, you specify the resource type of GitHub repository, the name of the repository, in this case it is example, and you can also specify the visibility here. So let's do one thing. Let's just copy this code and within our GitHub page, I'll add it. We do not want any additional configuration. We are just keeping it simple. All right. So if things are working, this should create a new GitHub repository in our account and the name would be example. So I'll save this. Let's clear the screen. I'll do a Terraform plan. So there is one to add, and what it is trying to add is a GitHub repository with the name of example. So let's clear the screen. Let's do a Terraform apply and see if the repository is getting successfully created. I'll do a yes. And great, the repository has been successfully created. Now, if you'll quickly look into the repository, here you see you have the example repository that has been created through Terraform. Great. So I hope this video has provided more better clarity related to how similar things are. So the overall area of defining the provider, defining the credentials for the provider, then from the documentation, you can look into the resource type that are available for the provider, then do a Terraform init, Terraform plan, Terraform apply. So all of those things remains to be the same. So in case if you know the basics of the provider, this is a prerequisite. For example, let's say you are responsible for creating Terraform code for Azure provider. So you should know the practical workings of Azure, how to create a new virtual machine manually through console. If your concepts related to the providers are understood, then you can easily write the Terraform code associated with it in great ease. So with this, we'll conclude today's video. Hi everyone and welcome back. Now in today's video we'll look into how we can destroy the resources that we have created through Terraform. Now one important part to remember specifically from cloud providers perspective is that if you keep the infrastructure running, you will get charged for it. Now generally from AWS perspective, they offer a free tier account where you can run the base services of a specific configurations free of cost. However, after 1 year, if your account is out of free tier, you will get charged for those services. Now, whenever you create a new resource through Terraform, the best practice is you terminate that resource after you have completed all of your testing. So at this stage, we had created two different resources through Terraform. One was a EC2 instance based on the AWS provider. Second one is a GitHub repository based on the GitHub provider. Now we are going to look in today's video on how we can delete the resources that we have created. So the approach number one is to destroy all of the resources. For example, if you run the Terraform destroy command, it will destroy all of the resources that you are created as part of a specific folder. For example, if you remember in our folder of KP Labs Terraform, we had specified two files. One was the first underscore ec2.tf and second one was github.tf. Both the tf files were part of the same folder itself. So from the client, if you run the Terraform destroy command, then all of the resources that are part of the folder will be terminated. So let's go ahead and quickly look into it. Now, as you remember, our folder of KP Labs Terraform has first underscore ec2.tf and github.tf. So from our CLI, from the KP Labs Terraform folder where both of the TF files are present, if we run the Terraform destroy command, you see it is trying to destroy two resources. The first one is the GitHub repository over here, and second one is our EC2 instance that we had created. And within here, it is asking for confirmation. You see, it is asking whether you want to confirm or not. So if I type yes, it will destroy all of them. But at this stage, I do not really want that because we are going to learn few more things related to this area in just a moment. So let me just type no and the destroy would be cancelled. Alright, so I hope with this you understood that if we run Terraform destroy, then all the resources that are part of the folder from which the command has run will be destroyed. Now sometimes the question that comes is, hey, I do not want all of the resources to be destroyed. For example, the server that I have created in AWS, I no longer need that server, but I need the GitHub repository to be in place. So in such cases, just by running the Terraform destroy will not help you. So here you have the approach number two. So in this approach, you specify the target flag, and in the target flag, you specify the exact resource that you want to destroy. So here you see, we have specified AWS underscore instance followed by the local name. And once you run that, only the EC2 instance that you have configured here will be destroyed and the GitHub repository continues to remain. So let's go ahead and understand this in a better term. Now, as we are discussing, the target options allows you to focus the attention on only a subset of resource and not all of the resource that are part of the folder. So the target flag uses the combination of resource type and the local resource name. For example, based on the code that we have written till now, there were two resource types that were defined: AWS underscore instance, GitHub underscore repository, and the local resource name myEC2 an example. So this can be better explained with this screenshot as well. So AWS underscore instance is a resource type and local resource name is myEC2, and GitHub underscore repository again is the resource type and example is the local resource name. So using the target flag, you can use the combination of resource type and local resource name to target a specific resource for destruction. So let's go ahead and also try it out. Now from the CLI, this time along with the Terraform destroy, I'll say target, and in the target, we'll use the AWS underscore instance followed by myEC2. So I'll say AWS underscore instance. I'll use a dot as a separator for resource type and local name, and I'll specify myEC2. Let's press enter. And this time you see only one to destroy. Let's verify what exactly it is destroying. It is destroying our EC2 instance. So let's go ahead and type yes. Now before we do that, from the AWS console, let's verify if the instance is running, and yes, our instance is running in the North Virginia region. So let's go ahead and type yes. Alright, so it took around 2.5 minutes for the entire destruction to be completed. Now, if you go to the instances, you see the instance state is terminated. In case if you still see instance state is running, just do a refresh from here and you see the instance state is terminated. Now, one more important thing that you need to remember is that although we have destroyed the resource, but we have still maintained the code associated with the EC2 instance in this file. So as long as the code is present in the TF file, Terraform will assume that you want to create this resource. So if I do a Terraform plan, Terraform will go ahead and it will recreate the EC2 instance that was terminated earlier. So here you see it states 1 to add. Now, if you will go a bit up, you see it is trying to create a new EC2 instance resource once more. So this is the reason why generally when you no longer need a specific infrastructure, you can remove this as part of the code. So either you remove this specific set of lines or you can just comment it out. Alright, if the code is commented out, Terraform will assume that it is no longer present and it will not perform any operations. For example, if you do a Terraform plan once more, this time Terraform will not go ahead and create the EC2 resource. Now, one more way in which you can destroy the resource. Let's say I have a GitHub repository that is present. I do not really want this repository. I can comment this out once more. And as we know, if a code is commented out, Terraform will assume that it is no longer present and it will destroy the resource associated with it. So now if I'll go ahead and do a Terraform plan once more, you see it is trying to destroy the GitHub repository this time. So there are multiple ways in which you can also destroy the resources in Terraform. Great. So I hope with this you understood the basics of Terraform destroy command and the flexibility that it offers. And with this we'll conclude today's video. Hey everyone and welcome back. Now in today's video we'll be discussing about the Terraform state file. Now this is a very important topic as far as Terraform is concerned. So in this video and also in the upcoming few videos, we'll be going ahead and discussing about the Terraform state file in great detail. Now in the earlier video, we had commented out the code associated with the GitHub as well as the code associated with the EC2 instance. So let's go ahead and remove our comment. Now we already know that we have destroyed the resource associated with the EC2 instance. However, we did not do a destroy on the GitHub. So our GitHub repository still exists. Now, when you do a Terraform plan, here you see that it is stating one to add, and what Terraform is trying to add, it is trying to add the EC2 instance. Now the question that comes is, how did Terraform know that our EC2 instance was destroyed and the GitHub repository is still existing? So how does it determine those aspects here? And that is what we'll be learning in today's video. Now, one important part that we should know is that the Terraform stores the state of the infrastructure that is being created from the Terraform files. And this state allows Terraform to map the real world resources to your existing configuration. We'll be discussing this in more detail in the upcoming few videos. But at a high level overview, just remember that whenever you create a resource, let's say you have created a resource of EC2 instance, Terraform behind the scenes, it also stores the information associated with this resource in a file called as Terraform state file. And through this specific state file, Terraform tracks your infrastructure related data. So for example, if you have created a EC2 instance and if you have created a GitHub repo, Terraform behind the scenes, it will store information associated with both of them in a Terraform state file. So here these on the right hand side are represented as a state file. Now, in case if you go ahead and destroy any of the resource, the associated state file for that resource is also removed. So this way, whenever you do a Terraform plan, Terraform will know that the GitHub repository state information is present. That means that a GitHub repository is created already. However, since the state information of our EC2 instance is empty, it means that a EC2 instance is not yet created, and hence it will go ahead and try to create the EC2 instance yet again. For example, whenever we did a Terraform plan, it was able to detect that the GitHub repository is already present, but the EC2 instance it is trying to create, primarily because the associated state of the EC2 instance is not present. So under the project where you are writing your Terraform file, there is one more file if you'll notice here called as the terraform.tf state file. And this is what we are interested in. Now within the Atom editor, if you look over here, we have one more file of terraform.tf state, and this is how the file looks like. Now again, we'll be discussing things in more detail, but as of now, just note that under the resources, it is just seeing that there is a resource of type GitHub repository. So if you'll go to GitHub, there is a resource type of GitHub repository that is being stored here, and it also has the exact provider related data and also the data related to the created GitHub repository. So the full name is demo kplab/terraform-repo. This is the git clone URL and various other information related to the resource. Now, since you do not really have any resource type of AWS_instance here, Terraform is able to easily detect that this specific resource is not yet created, or maybe it was created but it is destroyed now. So let's do one thing. Let's go ahead and do a Terraform destroy first. So as expected, you have one resource that was part of the state file. So Terraform know that this resource was created. So it will go ahead and destroy this resource only. That's great. So after this resource has been destroyed, if you look into the Terraform state file, here you see there are no resource. That basically means that everything is empty here. So now when you do a Terraform plan, Terraform will go ahead and not only create a EC2 instance, but it will also create a GitHub repository. So let's try it out. So let's do a Terraform plan. As expected, it is stating to add, and it is adding the GitHub repository as well as the EC2 instance. So let's do a Terraform apply and let's do a yes. That's great. So both of the resources are created. So let's quickly verify that. So let me refresh the EC2 console and our new EC2 instance is initializing. And now if you look into the Terraform TF state file, under the resource, you have one resource with the type of AWS underscore instance and the name is my EC2. So I hope you know the difference between the resource type and the resource local name. So this is the first one. And if you go a bit down, you have one more associated with the resource type of GitHub and the name of example. Now, one more important thing that you should know is that the state file contains the information associated with the resources that are currently live. For example, not only it will contain the information related to the instance and the local resource name, it also contains a lot of information other than that. So for example, let's go a bit down. So it is stating that the IP address of the instance is 34219. And if you look over here, the IP address is 34219. Along with that, under the security group, it states that it is using a default security group. And under the security here you see the name of the security group is default and the security group ID ends with 1BA. And the same information you can see over here. So the exact data about the resource that is running is also stored within the Terraform TF state file. And this is also one of the reasons why it is generally recommended to not really touch this specific TF state file. So if you're playing around with the TF state file through Atom Editor or any other thing, the chances are that things will really get messed up. So prefer not to directly go ahead and start editing this specific file. Also note that it is very important that you store the backup of the TF state file. In case if this file is not present, Terraform has no way of knowing the details about the infrastructure that is being created. So let's do one thing. Let's do a mess up and let's see on what would be the impact here. So for example, let's go ahead and remove the TF state file that is part of the folder. So this includes the TF state and the TF state backup. So I'll go ahead and I'll delete it. So now when you do a Terraform plan, you see it is trying to add both of the resources, not only our GitHub repository, but also our EC2 instance here. So let's do one thing. Let's go ahead and manually remove the repository here. So let's delete this repository. And now let's go ahead and do a Terraform apply. So the two resources are being created. Let's do a yes. That's great. So now under EC2, let's quickly refresh the console. You see that there is one instance here. So this is the instance that is under the initialization stage and this instance is managed via Terraform. You can also verify. So if you look into the instance ID, it ends with 22E. And within the state file, if you go a bit down, under the ID, again it ends with 22E. That's great. So I hope at a high level overview you understood the importance of a state file in Terraform. Hi everyone and welcome back. Now in today's video we will be discussing about one of the very important concept as part of Terraform, which is desired state and current state. Now one important thing to note is that Terraform's primary function is to create, modify and destroy the infrastructure resources to match the desired state that is described within the Terraform configuration. This is very important pointer. So basically whatever you write, whatever Terraform code you write within your configuration file, this is referred to as a desired state. Alright. So just to revise, Terraform's primary function is to create, modify and destroy the infrastructure resources to match the desired state. So in this screenshot, the desired state is EC2 instance with this specific image ID and with this specific instance type. So whenever you do a Terraform apply, since this is the desired state, Terraform will go ahead and create the infrastructure based on this specific configuration. Now tomorrow you go ahead and remove this specific lines from your configuration file. Terraform desired state would be no infrastructure at all. So Terraform will go ahead and remove all the resources that it had previously created. So this is referred to as a desired state. Now you also have a current state. So current state is the actual state of resource that is currently deployed. Now, important thing to note is that it is not always considered that the desired state is equal to the current state. Now, here you might assume that since the desired state is T2.micro instance, always T2 micro instance will be running. It can happen that someone is manually modifying the infrastructure from AWS side as well. So, your desired state and current state will not always match. So, in this specific slide, you will see the desired state is T2 micro. But in the current state, on the right hand side, the instance that is running is T2 medium. So your desired state and the current state are not matching at all. Alright. So these are two important concepts. Before we proceed further, let's go ahead and look into it practically. So for today's video, again, we are using a very simple file which creates a EC2 instance. So we have been using this configuration extensively. So we'll continue to use it. So from the CLI, let's go ahead and quickly do a Terraform init. And let's go ahead and do a Terraform plan to quickly verify if the code is fine. Alright, things seems to be good. So let's go ahead and do a Terraform apply. And we'll do a yes. So this will go ahead and create a new EC2 instance in AWS. So as we were discussing in the first slide, Terraform will primarily work to match the infrastructure that is defined in the desired state. So since this is a desired state, Terraform will go ahead and create an infra accordingly. Now, the second pointer, let's quickly refresh this region where the resource has been created. So this EC2 instance has been created in AWS. So now manually, let's go ahead and stop this EC2 instance. So the instance is stopped. Now let's go ahead and also change the instance type. So I'll go to actions, instance settings, change instance type, and let's change it to, let's say T2 medium. Alright, I'll do an apply. And let's go ahead and start the EC2 instance. So if I refresh the page, you'll see that the instance is running. So this specific instance that is currently running, this is the current state of the infrastructure. And the one that we have defined in the code is the desired state of the infrastructure. So now comes the important pointer. The important pointer states that the Terraform tries to ensure that the deployed infrastructure is always based on the desired state. So if there is a difference between the two, Terraform plan presents a description of the change necessary to achieve the desired state. So as we were discussing that on one hand we have a desired state, on one hand you have a current state. So when you do a Terraform plan or Terraform apply once more, Terraform will go ahead and modify that current infrastructure so that it matches to that of the desired state. So let's go ahead and quickly try it out. So I'll do a Terraform plan once more. So now it will go ahead and fetch the current state of the infrastructure and it will realize that the instance type has been changed. So here you see at this stage it has realized that the instance type has been changed and Terraform will go ahead and update the infrastructure to match that of the desired state. So let's go ahead and do a Terraform apply. I'll do a yes. Alright, so it took around 2 minutes and our infrastructure has been modified. Now if you'll quickly refresh the console over here, you see the instance type has now been modified back to T2 micro. Great. So I hope with this you understood the concept of desired state, the concept of current state and how both of them can be different in real world infrastructure. And Terraform tries to ensure that the deployed infrastructure, which is the current state, always matches to that of the desired state. So with this, we'll conclude today's video. Hey everyone and welcome back. Now in the earlier video we were discussing about the basics of desired and current state and how Terraform always tries to achieve the desired state. Now whenever you are dealing with production environments there are a lot of interesting scenarios that you will face with, and it is important for us to remember some of them. So let me show you one of the challenge that you might face in production, specifically when it comes to this topic here. For example, let's say that you have a EC2 instance that is running, and that EC2 instance is running based on this configuration. So the desired state as of now is equal to the current state. So everything is fine. Now, let's explore some of the attributes here. So under the security here, you see that this EC2 instance is associated with a security group of default. So now let's go ahead and try changing this security group. So for example, earlier the security group is default, and now what we want is we want to change this security group from default to custom. And now let's see on how Terraform behaves here. So let's go to the security group. Let's create a new security group here. The name is custom, and let's say custom security group. I'll go ahead and create it. That's great. So now let's go back to the instance and we'll change the security group associated with the instance from default to custom. So let's do a right click under the security. Let's change the security group. I'll select the custom security group here and I'll remove the default one here. So let's quickly verify. So now under security tab, you should see that you have a custom security group. Great. So I hope you got the use case that we are trying to achieve. Now, one of the questions that comes is, what will Terraform do now? So the straightforward answer that generally comes is Terraform will change back the security group from custom to default. So it will change the security group that we have added now to default. So let's try it out and see if that happens. If you'll observe the terraform.tf state file, let's look into the security group here. So the security group as of now is default. So now let's go ahead and do a Terraform refresh. That's great. Let's open the tf state file yet again. And if you look into the security group, it has changed from default to custom. Now, when you try to do a Terraform plan, here it states no changes, infrastructure is up to date. Now the question is why? So when you discuss about the desired state, if you look into this specific first PPT, it states that Terraform's primary function is to create, modify and destroy infrastructure resource to match the desired state described within the Terraform configuration. So the second part is very important, desired state described in a Terraform configuration. Now in this Terraform configuration, we never described the security group should be default. So the security group does not come as part of the desired state at all. So even though for the infrastructure you modify the configurations that are not part of the desired state, next time when you do a Terraform plan will not show you any details to revert those changes. And this is the reason why it is generally recommended that whenever you go ahead and create a resource like instance, do not just specify minimal things, specify all the important things that are necessary, including the IAM role, the security groups and various other areas as part of your Terraform configuration, so that it always matches the desired state whenever you run the Terraform plan in the future. Great. So I hope at a high level overview you understood the challenge and also the appropriate solution. Hey everyone and welcome back. Now in today's video we'll be discussing in detail about the provider versioning. So let's first go ahead and discuss at a high level overview about the architecture on how a provider might work. So let's assume that you have a TF file which goes ahead and it creates a resource. So let's assume that we are going ahead and creating a server in a DigitalOcean cloud provider. Now, once you have created this TF file with the help of Terraform and Terraform with the help of the underlying provider plugins, it interacts with the backend cloud provider. In this case, it is DigitalOcean. So for example, let's assume that under the do-droplet.tf, you have created a resource that goes ahead and creates the server. So then you do a Terraform apply. Terraform behind the scenes makes use of the provider plugins that have been initialized, and this provider plugins, it interacts with the do provider. So you have a API interaction that is happening, and then within the CLI output, once the server is created, you get the successful message here. So that is the high level overview about the provider architecture. Now, one important part to remember is that the provider plugins are released separately from the Terraform itself. So first is the Terraform version and second is the provider plugin version. So they have a different set of version numbers and they are developed independently. For example, let's say that you have a DigitalOcean provider plugin of version 1. Maybe at a later stage you might have a DigitalOcean provider plugin version 2. So even the versioning of a provider plugin, it keeps on updating at a regular interval, irrespective primarily of the Terraform version by itself. Now, at a high level overview, this seems good, but in production, it comes with its own set of challenges. So let's take an example of Microsoft Windows. So you have Windows 7, you have Windows 8, you have Windows 10 and so on. So Microsoft keeps on coming with the latest version of Windows. So let's assume that you are using Windows 7 and you're very comfortable with all of its underlying features. So tomorrow Microsoft comes with assuming Windows 10. So if you directly jump to Windows 10, lot of your existing programs, lot of things behind the scenes would change, due to which you will not be able to work efficiently or your applications would crash. And in a similar way, even for Terraform, it is very important, specifically for the production environments, to explicitly set the provider version. So generally, if you just do a Terraform init, if the version argument is not specified, then the most recent provider plugin will be used during the initialization phase. So this is the reason why what we do under the Terraform, we specify under the required providers the version of the provider related plugin. So for HashiCorp AWS, you have a version of 3.0 where the plugins would typically range on. Now, one of the question that comes is what exactly is this tilde mark and this specific symbol? So it is very important for us to understand on what are the arguments that you can set along with this specific version field in Terraform. So there are multiple ways in which we can go ahead and specify a specific version of a provider. So you have greater than equal to, you have less than equal to, then you have something called as tilde here, and you have greater than equal to comma less than equal to. So let's quickly look into it. So greater than equal to 1.0, this will ensure that whatever provider plugins that will be downloaded, it would be greater than equal to this specific version of 1.0. So you'll not see a provider plugin of 0.8 or 0.9 and so on. Then you have less than equal to 1.0. So this is less than equal to this specific version. So now you will not see a provider plugin of say 1.1, 1.2 and so on here. Then you have a tilde of 2.0. This basically means any version in the 2.x range. So it can be 2.1, 2.2, 2.20, 2.25 and so on. And then you also have a greater than equal to 2.10 as well as less than equal to 2.30. That basically means download the appropriate plugin ranging between the version of 2.10 and 2.30. So it will not be something like 2.8, 2.9, nor it will be something like 2.31, 2.32 and so on. So it is important for us to practically go ahead and look on how this would work. So for today's video, I have a folder of provider-versioning where we have one TF file called as provider_version.tf. And under this TF file, we only have the provider block primarily and this Terraform block. We do not have any resource that is being configured. So let's go ahead and discuss more about it. Now generally under the registry.terraform.io, whenever you go ahead and click on use provider, here you see that it explicitly comes up with a version. So here you have a explicit version that is defined, which is 3.27.0. So if you have this specific code, it will only go ahead and download this specific version here. However, as we are discussing, depending upon your requirement, there are a lot of other arguments that can also be set. The one that we are exploring today first is this third argument here. So when you have something like this where you have a tilde mark on 3.0, this basically means use any version in the 3.x range. Now x can be a variable here. Now do notice that our folder associated with provider versioning only has one file as of now. So let's go ahead and do a Terraform init. So currently it is going ahead and installing the version 3.27.0. However, maybe at a later stage, let's assume that there is a version of 3.30, then even 3.30 version can be installed here. And hence generally it is recommended in production environment to not directly use this, primarily because it might happen that the resource that you have written, it is working perfectly with 3.27. However, at a later stage, if 3.30 is downloaded, there can be some issues, and hence this kind of approach is also recommended. Now do note that as we have done the Terraform init, not only our provider related plugins were downloaded under the .terraform directory, but you also have one more file of .terraform.lock.hcl. So if you'll quickly open up this file here, under the provider you get the exact path of the provider of AWS, which is registry.terraform.io #AWS. Then you have the version which is 3.27.0, and then you have a constraint of 3.0. So this is the constraint that we have used. Now do note that since you have this specific log file available, at a later stage if you try to go ahead and change this specific version, it might not work. Let me give you an example. So let's change this version from 3.0 to 2.0. I'll save it. Let's clear the screen and let's do a Terraform init here. And immediately here you see you got an error. So here the error states could not retrieve the list of available version of the provider, and it states locked provider, which is 3.27.0, does not match the configured version constraint of 2.0 over here. So this log file primarily helps a lot specifically to stick to a specific version constraint that is being defined. Even though if you have modified your configuration here, if the log file is present, then it can block it. So let's do one thing. Let's go ahead and delete this file. And now if you do a Terraform init, so now it has been successfully initialized and the version is 2.70.0. That's great. So now let's go ahead and try various other version arguments here. So let's try less than equal to first. So just by mentioning 2.0, you have 2.70 version that is been downloaded. So let's go ahead and change this. I'll say less than equal to, let's say 2.60. Let's go ahead and save this. Let's also remove the log file. We'll clear the screen and let's do a Terraform init. Now based on this constraint that you have specified, now you see it is installing the version of 2.60.0 which matches your constraint over here. Now also note that within the description it states that Terraform has created a log file named .terraform.log.hcl to record the provider selection it has made above. So that is one part. Let's also try the last one, which is greater than equal to, comma, less than equal to. So this time let's say greater than equal to 2.10 and less than equal to 2.30. We'll go ahead and save it. Let's make sure to also remove the log file and let's do a Terraform init yet again. So now based on this constraint, now you see Terraform has selected the version of 2.30.0. Great. So I hope at a high level overview you understood the basics of version number arguments that you can specify under the required provider block. So now let's assume that you officially want to go ahead and switch to the version 3 of the provider, primarily because we are playing around with version 2 as of now. So in such cases, let's say that you have specified something like this, which is 3.0. So since there is a log file, we already know that whenever you do a Terraform init, this will be blocked. So then what you can go ahead and do is you can, if you want to have it, you can go ahead and do a Terraform init with the hyphen of upgrade flag. So now it will go ahead and find the latest version of the provider based on the constraints that you have set. So in my case, as of today, it is making use of 3.27.0, and then also your log file will be updated with the version that it has used. So for example, let's now look into the log.hcl. So now the log.hcl is back to 3.27.0. That's great. So before we go ahead and conclude, let's quickly revise the basics of the dependency log file. So the Terraform dependency log file allows us to log to a specific version of the provider. Now do note that this specific file that we are discussing, this is a newer one. So if you're using the older version like 0.11, 0.12, you will not see a file something similar to this here. So the second point states if a particular provider already has a selection recorded in the log file, Terraform will always reselect that version for installation even if a newer version has become available. So currently you have a 2.70.0. Tomorrow, even if a 3.0 version is available, Terraform will not go ahead and download the latest version of the provider when you do a Terraform init. And also, as we were discussing, you can override this behavior by adding the hyphen upgrade flag while using the Terraform init. Now, before we conclude, one of the questions that comes is, hey, my entire infrastructure is working perfectly with the version 1 of the provider plugin. Do I need to switch to version 2? And the answer is it depends. Many times what happens is, let's assume that currently DigitalOcean version 1 provider you are using, and after 1 week DigitalOcean has launched a new service. So that new service might not be directly supported with the version 1 of the provider. It will be supported with the version 2 of the provider. So if you have to create a resource with the newer service that DigitalOcean has launched after the version 1 provider got released, then you will have to switch to the newer provider version. So at a high level overview, this is one of the selection criterias. But even with the version 2, you have to do a proper amount of testing. There have been cases where an organization, they directly switch to the newer version of the provider and things break unexpectedly. That's great. So with this, we'll conclude today's video. It creates the infrastructure and it adds the details associated with it in the state file. Now, generally, this running infrastructure in any provider can be modified manually, and Terraform has no way to stop it. And this is the reason why, in case if the infrastructure is modified manually, Terraform needs to know about it so that it can revert to the original configuration that is part of the desired state. And this is where the refresh functionality comes into picture. So whenever you refresh the overall state, Terraform will go ahead and scan the real world infrastructure and then it will update the state as well. Now, one point that you need to keep a note of is that you will not be using the Terraform refresh command explicitly, primarily because whenever you run Terraform plan or Terraform apply, the refreshing actions are applied automatically. So you don't have to manually do that. So let's do one thing. Let's go ahead and quickly also try it out. Now for today's video, I have a very simple resource block that we have been using since a long time, which is creating the EC2 instance. Now again, you don't have to create the EC2 instance. I am just showing it so that our concepts are better understood. Now from the CLI, after you have initialized, you can run the Terraform apply with auto approve so that the EC2 instance gets created quickly. Now once the instance is created, now if you run the Terraform plan once more, one of the first steps that Terraform plan does is to refresh the infrastructure state. For example, here you see the first thing that it is doing is refreshing the state, and based on the current infrastructure, it matches to that of the desired one. And now it states that there have been no changes that have been made to the infrastructure. So at a high level overview, you should know that the refreshing of state is done by Terraform plan. Now, one thing that you have to keep in mind specifically related to the refresh functionality, as we know that the refresh automatically happens, so you don't have to do it manually. But sometimes if you do it manually, this can lead to a little dangerous situation. Let me quickly give you an overview. For example, at this stage, the Terraform plan is showing no changes in the infrastructure. That is completely fine. Now let's assume that you change the provider configuration. Instead of US East 1, I say US West 2. Alright, and I'll save the change. Let's clear the screen. This time, if I'll do a Terraform plan, before we do that, if you look into the Terraform TF state file, it basically shows you the details associated with the instance that is currently running. Now, if you run the Terraform plan, it is now showing that a new EC2 instance needs to be added, primarily because we have changed the region in the provider block and it is no longer able to find our older EC2 instance which was in the US East 1 region. So when you open up the terraform.tf state file, the file is still populated at this stage. So if you change this back to US East 1, I'll save the change. Let's clear the screen. Let's do a Terraform plan. Now it is able to find our EC2 instance and now it states no changes are required. Now let's take a second scenario where we will run the Terraform refresh. So let's change to US to West -2. Alright. Now when you run Terraform refresh, the TF state would get changed. So if I'll do a Terraform refresh here, again, it will not be able to find the infrastructure since we have changed the region in the provider configuration. And now if you see in the Terraform TF state file, it is completely empty. All of your configurations went away. And this is the reason why running the Terraform refresh related commands manually is pretty dangerous. It can remove your entire TF state file. However, we also have the TF state backup that is currently available, which we can make use of. So in fact, let me just copy this and add it here. In the refresh.tf, let me just change it to US East 1. I'll save it. Let's clear the screen. Let's do a Terraform plan once more. And if things are working, it should show no changes in the infrastructure. Alright, as expected. Great. So I hope with this you understood that Terraform refresh related functionality is already performed by plan and apply operation, so you don't have to do it manually. When you do a Terraform plan, the state file is not really modified. So even if the provider region is changed, if you run the refresh explicitly, this can lead you to a dangerous situation where your state is removed. So fortunately, since the backup was available, we were able to revert the changes. And this is also one of the reasons why in many of the remote backends like S3, versioning is also enabled. So in case if your state file gets messed up, you can revert to the earlier version. Now, one more thing that you need to keep a note of is that the Terraform refresh command by itself is deprecated in the newer version of Terraform. And in case if you would like, you can use the refresh only option for the Terraform plan and Terraform apply. However, most of the cases you will not be using that, but still from the exam perspective, this is something that you need to keep a note of. So with this, we'll conclude today's video and make sure that you destroy all the resources that you create for your practicals. Hi everyone and welcome back. Now in today's video we are going to discuss about the authentication configuration specific to the AWS provider. Now at this stage, for our initial demos and practicals as part of the course, to make things simpler, we have been manually hard-coding the AWS access and secret keys within the provider block itself within our Terraform configuration file. So here you see we have our access key, we have our secret key. Now although from working perspective this works pretty well, however this is not an optimal solution from security point of view. Many times it has been observed that developers, after they hard code the access secret keys, they commit the code directly to the GitHub repository. Sometimes the repositories are public by itself and the credentials are hence compromised. Even if the repository is private, any other user as part of the Git repo will be able to read your access and secret keys, and if they do anything wrong, the blame will directly come to you because your credentials were used. So it is recommended that you do not include the access and secret keys as part of your provider configuration. Now the question that comes is, if the access and secret keys are removed, how will Terraform connect to AWS and authenticate so that the resources can be created? So fortunately, HashiCorp has given us various other ways in which the authentication can work apart from hard coding the secrets as part of provider. So discussing about what we want to achieve, at the overview, we want our code to run successfully without hard coding the secret in the provider block. For example, this is how the provider block, even if it is defined in this way, things should work successfully well. So the only thing here is provider and we are specifying the region. That's about it. So in idle configuration, this code should work. So in today's video, we are going to look into how we can achieve certain steps through which this kind of a code would work successfully well. Now, one of the alternative ways which is much more better than hard coding the credentials is you specify the config and the credentials files here. So what you do, you add the credentials and the appropriate configuration in a separate file within your workstation, and then you add the location to these files. So even if you commit this specific code, the credential files are not present. They are in a different folder itself. And hence, even if you commit the code, there is nothing secret about it that can be leaked. So this is one approach. However, again here there is an issue, primarily because let's say that there are 10 people who are working with a specific Terraform Git repository. Now every person might have a different location in which they are storing the credentials file. So if the location is different, if you hard code the location path here, this can create issues specifically when larger teams are concerned. So what you'll have to do, you will have to achieve certain level of standardization where all of the team members will use the exact same path, and in the path they will have their own individual credentials. However, again, this is not the best of the approach, primarily because if we look into the earlier configuration, this looks much more sleek. It looks so well maintained and easy that would typically work across all the team members without a need of standardization. So here one important part to remember is that if the shared files that we were discussing, so these one, the shared config file and the shared credential files. So if these lines are not added to the provider block, then Terraform will locate these files at home.aws config and home AWS credentials on Linux and macOS. So these are the default locations where Terraform will search for the AWS credentials. And when we discuss about Windows, the path is user profile AWS config. You have a user profile AWS credentials. So now, even if you just specify provider AWS region US East 1, that should do. The credentials, if you have added to this specific path, Terraform will directly take it. Now, one of the important areas that I'll recommend specifically if you're working with Terraform from AWS perspective is to install AWS CLI. So at an overview, AWS CLI allows the customers to manage the resources directly from CLI. For example, if you want to create the EC2 instance in AWS, you do not really have to go through the AWS console, create the EC2 instance manually, etc. From the CLI, you can just add a command and the EC2 instance gets created for you. Now, when you are configuring the AWS CLI, the access and secret keys are also required. So the place where AWS CLI stores the access and secret key is the same location from which Terraform tries to search the credentials from, which is the AWS config and AWS credentials. So this path is the path where AWS CLI, it stores the credentials. So let's directly jump to practical to understand things in more detail. Now for today's video, in the KP Labs Terraform folder, apart from the .terraform which gets created on Terraform init, I have one file called as AWS provider-config.tf. Now within this specific file, we have specified a simple resource of IAM user. So all it does is it creates a AWS user called as KP Labs demo user. That's about it. And within here, as we're discussing, I have specified the access key and the secret key. Now we want to get away with this because of security issues. So let's do one thing. Before we proceed, let's test this code, post which we'll be making some changes and make our code much more secure. Now from our CLI, I'll quickly do a Terraform apply with auto approve so that this can save the time. Alright, so our AWS user is created successfully. Let me also quickly show you this. Where do you find the user? So if you go to the IAM service, in the users here, you have the KP Labs demo user. Alright, so this user got created successfully. Let's go ahead and also destroy the resource that we have created. Great, so the resource is destroyed. Now let's go ahead and remove these specific lines from our provider block. I'll save the change and temporarily I'll just add those lines to a text document so that our access key and secret keys are preserved here. Alright, so this is some random text document that you can create. Now, when you go ahead and try to do a Terraform plan, let's see what happens now. Immediately we got an error stating no valid credential sources for AWS provider found. So now what we can do, we can install the AWS CLI, we can configure the access and secret key as part of the CLI, which will be stored in these default locations that Terraform will try and find the credentials from. So from Google, when you search for AWS CLI, there is a specific page related to installing the CLI package. Now the CLI is available for Linux, macOS and Windows, and the installation is pretty straightforward. For example, if you're using the macOS, you have a GUI installer. So you can go ahead and download this package file. In fact, when you open this up, you see it gets downloaded. And from here, you can install the CLI. Now, in Windows, also you have a very similar approach. You have the MSI file. You can just open this up and the MSI file gets downloaded. You can open this up and the AWS CLI can get installed. Again, there are multiple other ways in case if you'd like, you have command line and other approaches. So for Windows, let me quickly show you. So I'll just open up the MSI. You have a simple setup. Let's go ahead and install the AWS CLI here. Great, and our AWS CLI is installed. Now you can open up the terminal once again after the CLI gets installed. To verify if it is successful, you can just type AWS and you should see the basic help related details here. So this means AWS CLI is installed successfully. So the next part is you have to run the AWS configure command, and within here you can add the access key and secret key. So we had stored the access and secret key in a text document. Let's copy this. I'll add it here. Let's also copy this. I'll add it here. And you can also specify the region if you'd like. And I'll save the change. Alright. So now what AWS CLI has done is that it has stored these credentials to a specific file. And which file it has stored? It is this specific location that we were discussing. In case if it is Linux and Mac, it is your home directory .aws config and home directory .aws credentials, and similar for Windows. Now let me quickly show you where do you find this in Windows. So in C drive, if I go to users, you have .aws here. So let's open up the .aws. You see there are two files. So even in Linux and Mac OS, in the .aws folder, you will have these two files. And inside these two files are the credentials stored. For example, if I'll quickly open this up with Notepad, you see this is where your credentials are stored. And if you do not mention any credentials as part of your provider block in Terraform, these are the files that Terraform will look as default. So once this is set, let's clear the screen and let's try to run the Terraform plan once again. Let's see what happens. You see this time it is working. You did not get an error. And if you want to confirm if things are working as expected, you can just do a Terraform apply with auto approve, and ideally the resources should be created for you. And you see our resource is successfully created. So now with this approach, even if you commit the code publicly, it does not really matter, primarily because the credentials are not present at all. Now before we conclude, I also wanted to show you details specifically related to the AWS provider. Now, here we were discussing about few ways in which we can achieve authentication as part of AWS provider. For example, we were discussing about this approach where access and secret keys were used. Along with that, you can also make use of environment variables if you like. So you export certain environment variables like access key, secret key within your CLI, and this approach will also work. Along with that, as we're discussing, you can make use of shared config files and shared credentials files approach as well, which also works. If you do not specify this, then the .aws credentials and config files will be taken by default. Apart from that, there are a lot of other ways. For example, you can assume a IAM role. So you have role, ARN session, etc. This is also quite useful. Now, since this is not a AWS specific course of Terraform, we are not going into too much detail, but the things that we are discussing as part of today's video is the standard approach which you will generally see in production environment workstations for the users who are actively working with Terraform. But anyways, in case if you'd like to dig deep down, you can also refer to the AWS provider documentation if you'd like. Now, generally, the AWS CLI based approach is not only beneficial for the current use case, but specifically when you have some kind of a single sign on solution, maybe Okta, maybe AWS SSO. This is where AWS CLI also helps. And this is the reason why it is generally recommended that if you're working with AWS, use the AWS CLI for storing the credentials. Alright, so that's a very high level overview about the authentication configuration. Now, one more thing that I wanted to discuss before we conclude the video is that this is relatively a newer video after the course was launched. So earlier we had a similar video at a later part of the course in the security section, but I decided that it is better to add it in the initial section of the course itself so that everyone can start to write a code which is much more secure. Sometimes we have seen students, they directly copy paste the entire code along with the credentials over here. So they'll paste the entire code in the Q&A section stating that some things are not working or Terraform code is giving an error. So then as an instructor, we have to remove the question primarily because the access and secret keys are already leaked. And then we have to message with the user, we have to coordinate them to deactivate the key, generate new set of keys and so on. So in the initial part of the course itself, I thought that it will be better if we remove the keys here. But in the first few videos, we decided that we'll use the key-based approach so that we understand the disadvantages that this approach provides. So in the later videos, you might still see that many of the videos might have this primarily because this video of authentication configuration is relatively new video compared to others. So in case if you still see the access and secret key in the other videos, you can simply remove them primarily because the AWS CLI is already configured in your system. So that's a high level overview, and with this we'll conclude today's video.